Hello Year 11 and welcome to our fourth video here for our fifth topic being transformations. We have looked at so far during this topic in 4a, we looked at translations up and down, side to side. Right? How did we do that? By adding a constant, right? That'll up and down, or by replacing x with x minus L, let's say x minus something, and that'll move it side to side. Okay, well good. Up and down, side to side, that is a translation, a special type of transformation. In our second video, just to recap things, we looked at reflections. Okay, we reflected about the y-axis by replacing x with negative x, and we reflected about the x-axis by replacing the function of x with the negative function of x. In 4c, we looked at odd and even functions, remembering not all functions are odd or even, some are neither. But even functions display line symmetry in the y-axis, and odd functions display rotational symmetry about the origin. And I can test for them by substituting negative x. But today, absolute values, right? In this case, we're talking about the absolute value of a number is something like its size or its magnitude, right? Without its direction, right? We don't have negatives. And what we do is we take the negative away. I'm just interested in the size of the number. We represent the absolute value of x by putting these sort of vertical lines either side of it, these bars, okay? It looks like that. You can see it there on the graphs, on the notes. Now, these share some characteristics with parabolas, I suppose, the graphs of these things, because they sort of change direction. They turn around, change direction, and consequently, we might have, as a solution to an absolute value in an equation, we might have 0, 1, or 2 solutions. What does that mean? Well, here's an example. We're asked to solve this absolute value equation. Now, this is the technique for dealing with them. Okay, keep in mind, this could be a question in your HSC, theoretically. Okay, these pop up fairly regularly, right at the beginning. What we do is, we consider two cases, where x minus 3 equals 4, and when x minus 3 equals negative 4. I forgot these transitions are rubbish. Sorry. So, here we go. X minus 3 equals 4, or x minus 3 equals negative 4. Then we can solve those. If we add 3 to both sides, frankly, both of them, I will get x equals 7, or I'll get x equals negative 1. So there's my solutions. I have two solutions in that case, two solutions, get them. X equals 7 and x equals negative 1. And that's really done. But, you know what's nice? I like a graphical solution to these sorts of things. So, let's consider a graph of y equals the absolute value of x minus 3. And a graph of y equals 4, right? Graph at the left-hand side, graph at the right-hand side. Where they intersect, that'll be where they're equal. What would that look like? Well, y equals 4 is a horizontal line. And x minus 3, we are taking the absolute value of x, this sort of V shape, and moving it, translating it, if you will, 3 units to the right. See, we replaced x with x minus 3. So here we go. We've moved that point 3 units from the origin across to the right. Okay, we get this sort of a shape here. We can find those intercepts, we can substitute or something. But anyway, here's the line y equals 4. That's the black dotted line running horizontally across the page. And we can read off where those lines intersect. So at 7 here and at negative 1 here. That's a nice, neat graphical solution to that problem, as well as solving an absolute value equation. And a reminder, how do we do it? Right, we consider the positive and the negative case, essentially. Okay, that's it. That's the last example for the last video in this fifth topic. Hope it's been worthwhile. If you've got any questions, you know I'm only too happy to help. Thanks, guys. Enjoy.